Okay, so what we're going to do is talk about CLI. It's brand new and exciting. Everybody loves CLI. We don't want that fast networking stuff. This is where it's all at, right? Nobody agrees? Okay. Okay, so for me, I've been looking for some sort of command line interface tool I can use for years. It's been difficult for me to find it. Either they do very, very little, or they do way too much. And then there's some that are in between, and some that are, you know, a couple of kbytes that do little of nothing, and there's some that are megabytes in size that do everything. So I've been looking at a lot of different ones, TCL, Python, all those other things, just trying to figure out how to make it work. And nothing really grabbed me, I guess. I'm from more of an embedded world, so I like to see things that are more standalone and we can utilize and make it quick. And I know the command line interface we have today, it's pretty difficult to use as far as getting a new command put in quickly and be able to understand how it works. So a lot of them are written in C++ or something else, or Python or some other language, and those are good, but they're too big. They're too difficult to put into a small system. Now, DPDK basically isn't necessarily a small system, but I still think that way. So we have a lot of conversions. A lot of these APIs do a lot of conversions, and that's really difficult, in my case, to have you convert that data for you automatically. It sounds like a great idea, but a lot of times we don't have all the conversions that we need. And then that's kind of evident in the current command line one. Just to put in package in, I had to add new ones, and those were difficult to put in and deal with. So I just left a bad taste in my mouth. And plus, it seems to be a lot of code. So I decided one Christmas break, I'd go ahead and write my own. I finally figured out what I think I needed. So I decided, well, it needs to be quick. It needs to be quick for a developer to put a new command in. And it needs to be dynamic. It needs to use interfaces that are well known to developers, not some new structure that I decided to come up with. Biggest goal is that you really want to put in a new command when you're building your system. It may not be in a production piece, but you're building it. You want to put it in a debug or whatever. You don't want to take 4 days to put it in. So a lot of times you don't. So what you want to do is really put one in very quickly and make it work for you. So also a CLI shouldn't be necessarily static. It should be dynamic. You should be able to add commands and take commands away. Like if you have a system with multiple users that log into that system with different privilege levels, you'd like to be able to tailor the commands they can use to what they want. So with all those pieces put in together, I said, well, I like that. I also like, you know, like a shell or a command line type entity where you have directory trees that you can CD around into and deal with. Those make a lot of sense to me. And then you can also then tailor your commands to the path that it sits in if you have it in a directory tree, if you want. You don't have to. You have to have the obligatory stuff, the autocomplete, the history, things like that, maybe environment variables, things like that. So those all need to be there at some point or another. So there's a bunch of other features, but you kind of get the picture. So the clock isn't running down here. Is that a good thing or a bad thing? So I get infinite time. So right now with CLI, it has no global variables. So you can actually run multiple instances of CLI on the same process in the same address space. That may not seem like a big thing, but if you think about multiple levels of privilege for people, it becomes a big thing. Okay? We also support, or in my version, we support files. Now the files are callback associated, meaning that they can be static data, or they'll call back to a function. You can provide this data dynamically from that file. You can even write to these files. You can even save them off, but I didn't provide the save mechanism. You'll have to do that yourself. Also have simple aliases, allow you to create an alias for something, and I'll show you one, hopefully when we get to the example here. And of course, it's directories. CD and around, ls, those kind of things that you've seen, make dir, that kind of thing. So you can add those. But you can also add them from programmability, meaning from the code itself. You bring in a new .o, let's say, you link it into your image, dynamically, you can then add a whole new directory or a whole new set of commands on the fly if you want, or take them away whenever an application goes away. So really the callbacks for these commands and files and so forth are argc, argv format. That's all it is. It's just like main, main, argc, argv. That's it. I don't do any conversions for you because chances are I'll get it wrong anyway. And I don't like doing conversions. You can do those conversions because you know what the command needs to do and what the options need to be. So the structures can be removed and added, as I stated before. There's simple environment variable support. So you can have environment variables. You'll have to save those off if you want to keep them. But they're there, and you can deal with it. It's the same thing as you've seen before. There's also, in the relationship of, yes, all the commands can be, in our current configuration, they're all at one level. They all sit at one particular, call it a directory level if you want to call it that. They all sit in bin. Well, maybe you can have different bin directories, and you can have multiple bin directories within this system with different command sets. Or you can cd into a particular directory and execute that command in there, and it's specific to that path. There's something else for the commands themselves. If you create a very complex command that has a lot of arguments, you need to be able to describe that so that you can actually find it. If you do a lot of things with test-pmd today, you'll see a lot of cases where they have to do a lot of stuff to get around the different commands that are in the system. Because there's really only one command level. But in here you can have multiple command levels. Plus you want to be able to deal with how you parse that command. So I created something called a map interface, which is just basically a printf style of strings that tell you what that command looks like. And then I'll search for the best match and give it to you and call back your routine. And it's a simple table. We'll see that in a minute as well. So whenever I did this, I said, test-pmd and even in package-gen, my command.line.c file is very huge, bigger than I expected it to be. And in this particular case, the command.line.c file in test-pmd at the time I did this was about 12K lines of code. It's a lot of code, a lot of structures to deal with. I was able to reduce that to about 4.5K lines of code because I reduced the complexity. I didn't make you create all these new structures and all this new stuff, and it's not static, it's all dynamic now. So all those structures you're ever create and all those macros that seem to be magic macros doing all this stuff. It took me about 2 days to do that. Well, that's me because I understood what I was converting to, but it was much easier to deal with. I used most of the code, the core code of what the actual command did versus how it got there. And that's where the reduction in lines of code came from. I converted these to what they call the map interface for me, which is those series of command lines. So if you have a flow command line with multiple arguments, and you had to create umpteen different functions and 14 different structures to describe those functions or those command lines, you just do it in a simple printf string now. And it's much easier to follow with special formatting. So this is kind of the first start of it. Now in command line, it's pretty easy to start it up. So not saying that this is anything new for anybody. But this is basically what happens here. You start it up with the defaults, and I actually give you a set of commands like ls and cd and that kind of thing that you'll already have in bin, and you'll have a root directory, okay? And then if that works, obviously, it doesn't fail, you can do CLI start. And that null there you see there is for messages, for a one-time message that comes up. And then when you leave, it'll destroy it and you're done. So that seems pretty easy, right? So here's a little bit more complex one. It's more of a hello world. You can see this one here, this hi command up here. That's the command that you get called back with whenever you type in hello. It gets an argc and an argv format. It's your job to parse it. If you look a little bit further down, you'll see this little structure here. and these little commands, c_dir, c_command, c_end. Those are macros for that structure, just to make it a little simpler. So when you do a dir, it says, I'll create a directory for you in this spot called bin. Oh, by the way, now that you're in bin, I'll add a command called hi or hello. And there is the function to call and this little help string for it. So back over here, if you go down to main here, you'll see where I did create the CLI with a tree. And I pointed it to my own tree, little routine here. And he takes that and then initializes. The first one is default tree init, which gives you the commands like ls, cd, and that kind of thing. If you don't want them, don't call it. I'm not telling you to put anything in here yet. But I'll go ahead and add my own tree, and that's what the next command is. And then I'll specify that that bin path is now a searchable, executable path. And that's it, for the whole command. Significantly less work, I think, and a lot more easier to understand than our original one today. Now, I'm kind of rushing through this a little bit to try to get to a little demo I have, and I may have quite a bit of time left over, I don't know, but we can at least answer questions. So the command line is up on dpdk.org. It's pushing its own draft repository right now. You can pull it down and play with it, look at it, do whatever you want with it. It's specifically built for DPDK. It uses DPDK constructs, it uses DPDK headers, it uses things like that. So I didn't write this to be generic, meaning anybody can use it for anything, but I really wrote it for DPDK, just to take advantage of some of the pieces that are in DPDK already. That could change. We could convert it to a standalone one and make it whatever, but that was not my purpose in life. We can argue that point if you like. Also, if you want to play with it, other than just the examples, you can pull down package_n. Package_n now uses that command line interface. It makes it so much easier for me to add a new command and parse it with those map files. There's also a couple of header files and directories there. Let's see here. Now we're going to try to pop over to a little simple demo that I'm going to run in the VM here. Let's see if this init powered down. Here we go. See if I can type my password all at once. Okay, so right here I have one built into my tree as an example, and I'm just going to execute it, and that's what you get. You can change that prompt to be whatever you want. It's up to you. Change it on the fly, put it up front, make it dynamic prompt. It's up to you, because that's just a callback as well. So right now we just have the familiar commands like ls. And you'll notice I have a couple of things here. I have a DPDK version, which I created in this directory. If you were to do a more and do a tab, it'll do autocomplete for that, and it'll actually print out what the version of DPDK is. It's just a simple callback. If you want to see the copyright, another one, and it's a simple more. There's nothing complex about more. We go back to this view, you can see all the commands, but if you want to see more than that, you can actually see what all is there in a long listing. You can also make it recursive. So this is part of hello. What he does is he just goes through all the directories and tries to print out whatever the hello string is or help string is located for it. So it just says, hey, these are what these are. Nothing complex. You can make them as complex or as simple as you like. This command, ll, is just an alias, and it's an alias to ls-l. That's all it is. And it's just a simple string that's put into the file, into your code. We can look at that if you like. But as you notice, we have a pwd. We have all the standard stuff that you want. You can cd down into bin, do a hello. We have history. You can scroll through history with the up and down arrow keys. Okay? And see everything. We have an sbin directory, which is what I put in there originally, is your kind of your default stuff. So we have an environment. I just put 2 in there right now. You can change that however you like. We have something else that's handy for people to use, CMap, similar to the same scripting stuff you get in other places. So in this particular case, we're just using that particular piece of code, and now you can see where your cores are located at and where your threads are located at. You can also look at huge pages, see how many huge pages you have in the system. It's just a simple call out. All I did was grep to the to procfs in memconf and grepped out just those pages. That's all I did. Super simple, nothing complex. You can actually run scripts in this thing. Now I usually use Lua, but you can also run command line scripts as well. Come from the command line or from pull it up here. You can have the script in here, or you can have it in the file system, in the actual real file system. If you go ahead and type in help, it shows you everything that's there. I didn't want to use help because somebody else might use it. So it kind of tells you here. You can actually execute a history line with a number, whatever that is. Right? So that's a PWD, it looks like. So you can also then do an exclamation point and list what's in the main directory or execute any Linux-based command. You can turn those off as well. So that's really kind of the simple path to it all. There's probably a lot more commands that you want. Like you have the version string here, just prints out DPDK version. The file over there could have done the same thing, what have you. But anyway, you get the gist of what's going on here. It's super simple to edit and add these files. Main.c is not a huge file. There's the hello command. I allowed you to put hello and something else after it, made it a little more complex than just hello world. This is a PC file. This allows you to access the PCI list in the system. So there's a command in there that says PCI, and it'll dump out the entire PCI bus for you. And you notice it's just doing a system call, really. You notice here's all the commands that I'm going to add. PCI, bin, hello, this one here. You notice with the ls, the alias, just ls-l, because I already defined the command. Here's the tree, and that's that whole command. Now in the other pieces for DPDK, like test-pmd, it's very, very similar. Now one of the things that we don't do, and I could show you quickly, I guess, if we can get to it, and can type. I'm going to go try to find one of those map pieces here as soon as we get through all the help. There's thousands of. So this is set. As you can tell, there's a number in front of each one of these lines. There's the command itself, and then basically a string. And that string has, like this one, set command, that %OR says this is an option. So it could be either MB ports, MB cores, burst, verbose, and then %D means it's a number. That's all it means. There's the ones for %M, %D for 64-bit values instead of 32-bit values, and so forth. This number over here at the side is just an arbitrary number. It has to be unique per line or per map file, but it's just used as an index. And you can see little functions that help us here. It's just an index into this case statement. So 20 is this one, set CPU core mask, blah. And you just handle whatever happens at that particular spot. So it's pretty simple. So that's really the end of my presentation. I'd like to get some help in making sure it tests for test-pmd and that we get it integrated into DPDK. But that's about it. Is there any questions people would like to have? I think it's a good idea, bad idea, who cares? Okay, Thank you very much.